Part 2. Let's talk about energy transfer. Energy can be transferred through particle collisions, meaning two things touching. If this thing is hot and it touches my other finger, it's going to make my other finger hot. All right? So that is because of conduction. Conduction is when energy transfers through a material, and it requires two objects that are touching. So for example, a hot pan on a stove. When I turn the stove on, it heats the pan and sends the energy from the stove to the pan, and then the energy from the pan to the food that I'm cooking. That's conduction. So an example would be cooking on a stove. Convection is the transfer of heated material caused by hot air expanding and rising and cool air condensing and falling. An example is boiling water. The hot water rises, and then the cool water sinks. And then rises, and then sinks, and then rises and sinks, and you get this convection current. Let me show you. Here is an excellent example of convection, when hot particles rise and cold particles fall. I thought I'd be able to put pennies in here so you could watch them rise with the bubbles and then fall around the sides, but they're just too heavy. I don't have enough water in here. If this was a big pot of boiling water, it would probably be able to do it. But what you're seeing is the particles that are touching the stove, which is the bottom of the speaker, okay? That's conduction. Because those two surfaces are touching, I'm heating up the bottom of the beaker. Then the bottom of the beaker is heating up the water in the bottom of the beaker. Convection is when that warm water rises, and then it comes all the way to the top where it cools down, and then it sinks down the sides. You can see this rolling effect happening right here. That's where the water is rising and then falling. So that's convection. Convection is hot air rises, cold air falls. It's basically a stirring motion. Conduction is when two things are touching and the heat is transferring from the metal coils to the bottom of the beaker, then transferring from the bottom of the beaker to the water. Another really good example of convection would be a lava lamp. If you want to see this in action, Google a lava lamp. Radiation is a type of energy that is transferred by electromagnetic waves. Electromagnetic waves is basically another way of saying sunlight or photons. There's no matter. You can't touch sunlight. It doesn't have any weight, and it doesn't take up any space. So it's not considered to be matter. Instead, it's transferring energy not because it's touching something, but simply because it's sending enough energy in those electromagnetic waves or wavelengths of light to be able to transfer the heat from the sun to another object. In order to demonstrate this, we're going to be building solar ovens, and you are going to take the energy from the sun and you are going to transfer it into something you're going to cook in your ovens, like cookies. Okay? I'll show you that in a minute. An example of this can be sunburn. You're not actually touching the sun. The sun is not actually touching you. It's really, really far away. But it's sending energy in the form of these electromagnetic waves that we call photons, or we call it light. It's sending that energy in the form of light. It hits our skin, transfers that energy to our skin, makes our skin molecules vibrate so fast that you get a burn. You get a sunburn. All right, and then lastly, conductors and insulators. A conductor is any material that makes this stuff happen better. So energy can be transferred really easily in conductors, things that get hot easily. So examples are metal. If I have something metal in a fire pit, I do not want to grab it. I'm going to get burnt because the energy from the fire pit is going to travel up that metal to my hand. Same thing with touching a hot pan out of the stove. The stove is heating up that pan. If it's made out of metal, I don't want to grab it with my skin because the energy will get transferred from the pan to my hands. Metal is a great conductor. Insulators are where energy cannot be easily transferred. That's how thermoses work. If you look at a thermos, if you were to take this thermos and cut it in half, you would see that it has the inside portion, and then there's your outside portion. Okay, and then you put the lid on here, and that's where you drink from. But when your liquids are in here, this space acts as an insulator. That empty space. Sunlight or heat particles are hitting the outside of this container. So how do we keep our liquids cool? If there's ice in here, how do we keep it cold when it's being hit from all sides with radiation, sunlight? Okay? Well, the only way that the heat from the sun can get to this ice water is if it touches a molecule, that touches a molecule, that touches a molecule, touches a molecule, touches the inside of this container. Then when that heat touches the inside of the container, it touches the liquid inside here, and now you're transferring your heat in here. If you take away all of the particles and make this a vacuum, meaning no air whatsoever, it is empty, then there's nothing to take the heat from here to here. It is a void. The only way heat can get from here to here is if one thing touches the next thing, just like in conduction. In conduction, two objects have to be touching. Those two objects can be air molecules. So if you take all the air molecules out, then you're not going to pass the heat and your ice will stay frozen. The same thing works if I have soup in here. This is hot. And maybe it's cold outside. I don't want my soup to get cold. Or maybe I don't want my coffee to get cold. So, if there's no air in here, the hot particles that are in here are never going to get out because there's no way to transfer the heat from here to here. That's how a thermos works. So these are things that make it so you don't get burned. It keeps things cool. An example is the rubber coating on wires. If you look at your cell phone charger, it's not all exposed wires. If these wires were exposed, I would be getting electrocuted every time I plug in my phone or my earbuds. So all the metal that's in here, which is a really good conductor of electricity and heat, I am surrounding it by an insulator, which does not transfer that heat. Therefore, I can touch it without getting burnt. When you build your solar ovens, you need to make sure you have conductors in there, things that are going to get hot. So when the sunlight hits it, it's absorbing that sunlight and really warming up. Then you also have to have an insulator to make sure that that heat you're creating and capturing doesn't escape. So make sure when you're doing your solar ovens, you have conductors and insulators. That's going to lead us to part 3 of this week's assignment.